Yeah, there's so many laws in the chemistry world, but today we're talking about just one. Yeah, word. Charles' law, yeah, it sounds fancy. In reality, it's just about the basketball, being bouncy. V1 over T1 equals V2 over T2. It's the equation. Please listen up, sit down, and be patient.
Hey H-Block, Kelsey here. I'm here today to talk about the Charles Law.
Not that, Charles! Yep, that's the one.
Okay, the Charles Law is defined as, write this down. The Charles Law states that as long as the pressure and temperature are constant, as the temperature of a container increases, the pressure will increase, and vice versa. The same goes for decreasing pressure.
Keep going. The equation to express this is V1 over T1 equals V2 over T2. On June 5th, 1873, two guys named Joseph and Montgolfier used a fire to inflate a spherical balloon about 30 feet in diameter. So it was basically a hot air balloon that they used because as the temperature increased, the volume inside of the hot air balloon increased, causing it to float. The balloon traveled about 1.5 miles before it came down to Earth. News of this amazing achievement spread throughout France, and Charles tried to duplicate their performance. After spending much time with balloons, Charles noticed that the volume of gas is directly proportional to its temperature.
Practice problem. Number 1.
Saddam was celebrating her 17th birthday and she was planning a huge party. She went out and bought party hats, drinks, food, and a bunch of balloons. She spent almost a whole afternoon blowing up balloons with her sister. While Saddam is blowing up a balloon, it's blown until it reaches 2.85 liters at 25 degrees Celsius. When putting the balloons in her room, she accidentally left the 2.85 liter balloon in the living room. When she came back later, the balloon had popped on the floor. She checked the temperature and it was 200 degrees Celsius. She realized that it must have been too hot and the balloon expanded. What was the volume when it popped at 200 degrees Celsius?
Here's a ping pong ball. It's plastic. With experiment, it's fantastic. You can see this dent created in the ball, but after this experiment, you don't see it at all.
For our demonstration, we decided to reproduce the dented ping pong ball in boiling water experiment.
What does a dented ping pong ball in water have to do with Charles' Law?
Well, when you put the dented ping pong ball in the boiling water, the temperature of the gas increases because the water on the outside is heating the gas inside. Charles' Law states that when a gas's temperature is increased, it will take up more space.
The pressure will remain constant. As the air inside the ping pong ball heats up, it expands to take up more space. Because it has to take up more space, it forces the dented plastic out to create space inside, making the ball round again.
Let's see, how's it even? It already worked.
Look at that.
And there's no dents anywhere. Can you see this?
That's Charles' Law for you.
There you have it.
Practice problem. Another one.
It was the first day of summer and Kelly couldn't wait to get in the pool for the first time, but she only wanted to lay out on the water and tan instead of swimming. So she decided to break out some new pool inflatables her mother had bought. While blowing up a pool inflatable, it was 30 degrees Celsius. Kelly put enough air in it to give it a squeeze, not too little air and not too much. When she was done, the volume in the floaty was about 4.5 liters full of air. The temperature increased and the inflatable popped at 30 liters, sending Kelly straight into the water. What temperature in degrees Celsius did the inflatable pop?
You can see volume and temperature can create a chemistry explanation, that's for sure. Volume over temperature is the way the equation goes. Hope you listen closely, now the gas law is known.